Right. So with Avogadro, there could be several issues that are causing problems and the things that I would look for. So some of you are saying that you're not seeing the vibrational analysis coming up when you open an Avogadro. So the first thing I would look at is what I can do on the clusters. I can look at the log and I can edit the log. I don't want to edit really. I just want to look at it. So please don't save if you do something like this. So the first thing I'll do is I want to have a look inside the log file.
Yeah, okay. They are coming. Yeah. Okay.
Okay. And towards the top, I can see, I can check at the top that this log file came from an opt and freak. So I'm certain then that this should provide us with vibrational. Let me just see. I'm going to copy it onto my desktop and let's try and see if Avogadro will pick up the vibrations. I don't use Avogadro that much. I tend to work quite a lot using Babel and with text files. For orbitals, I'll often use Gauss View, but we only have that under Linux on the cluster. Has Avogadro not started? Let me just check. Avogadro. There we go. Okay, I'm not. There we go. There's Avogadro. And if I just open on my desktop, you can see immediately the vibrations are there. So there's no issues with that particular file. But of course, I can't see the orbitals now because I don't have directly there in the same thing the formatted checkpoint file. So it's looking for that formatted checkpoint file, but it's not finding it. Okay. Right. So the other thing that might happen is if you copy the checkpoint file, the unformatted one, I don't think Avogadro can handle the checkpoint file. We'll see. So this would be the wrong file to have available. Okay. You really want the formatted. Remember that on the cluster you would have to do form check, and that creates a checkpoint file that's readable by many, many other programs. Okay, let's go back to Avogadro and let's open. And now, because it's the wrong file, it won't show you the orbitals at all because it's not the checkpoint file. Okay, it's not the formatted checkpoint file. Okay, so it has to be this FCHK and it has to be generated using form check. So if you copy that across, then we are in business. And I'm going to just delete that other one because we don't need it. Okay, just please, if these names are slightly different, other than the .log and the .fchk, then it doesn't know that they're associated together. So also just make sure that these have exactly the right names as each other. You can see letter for letter, it has to be identical. Then it will work. Okay, and then if you open the log file, just please check that you're opening the log file, not the formatted checkpoint file. Open the log file, because I think it's the log file that has the vibrations in, and the formatted checkpoint file that has the orbitals in for you to be able to work with. Okay. If you've got an exact problem, it's nice for you to tell me because I can copy the two files and I can troubleshoot in front of you. And if you see me troubleshoot, then it gives you greater experience in your troubleshooting and helping each other. Okay. So rather than me troubleshoot from a distance, troubleshoot with you, and that will sort things out. Okay. Okay. Right. So what I want to do, any questions on that? Okay. So what I want to do now is I want to do a redocking. So what I've done using Marvin Sketch is I have recreated that ligand for 5-REC, for the 5-REC protein. I've recreated that ligand. And can you see that I have optimized it with XTB? So I'm going to copy that into this receptors folder here because using Autodoc tools, I can have a look at that ligand and I can prepare the ligand and make sure that the torsions are all set on that particular ligand. So let's see. Okay, so let's first change the preferences to be the current working directory, which is, there we go. Okay. There may be a more efficient way to set the startup directory, but this is the way I do it. Okay. So what I want to do is I want not to look at receptors now, but to look at the ligand itself. And the input I'm going to open is not a PDB-QT file. It's straight off the cluster as a PDB file. And it's the ligand that I made from XTB. Okay, so here we go. Here's the ligand from XTB. And you'll notice that when I open it, it only leaves hydrogens on it that can be hydrogen bonded. And if we can go to the torsion tree and we ask it to choose torsions, I don't want to change them, you'll see it's marked in green. There's 4 rotatable bonds. So to search conformations of this particular molecule, it will rotate around those 4 bonds trying to search for a conformation. Okay, so that's really important. All I want to do is I want to output and I'll save it as a PDB-QT. And so 5-REC, I'm not going to change the name. It will automatically add that PDB-QT to it. So what we have now is a receptor and a ligand that I want to redock to it. Of course, you don't always want to redock. Sometimes you want to dock a novel compound, something that's new. And we'll do that. We can do that a bit later on. But why I want to redock is I want to make sure that I've validated the docking procedure. Okay, so I want to check that when I do the docking, it goes exactly to the active site as it was before. And sometimes that can be a little bit tough, but let's see how close we can get it without spending too much time trying to refine it. Okay, so I have a ligand open in the workspace, and that ligand is saved as PDB-QT. It's all set up perfectly for a molecular docking experiment. One thing that I maybe just quickly need to know is I need to maybe remind myself of where the active site is for 5-REC. So maybe Discovery Studio is quite nice. Because if I open 5-REC, I can just quickly have a look at so let's go File, Open URL, 5-REC. So there we go, and I'll just take the S of HTTPS. You can, in the preferences, you can change it so it works every time without you having to change the S. File, Open URL. Okay. No. Okay, there we go. I was just not patient enough. But here is the co-crystallized ligand, and I'm going to use a central atom there to tell me where the active site is. So I'm just going to right-click on the atom and go, what are the attributes of that nitrogen? And we can see 22.7, 15.4, and 4.5 is the exact position in Cartesian coordinates of that atom. And so that's a really good space to search for other ligands to check whether they're going to fit in the active site of this protein. Okay, so I'm going to leave this open. I'll come back to it. But when we need that, those numbers are then available. So in Autodoc tools, we've used the ligand to open the ligand, but that's one thing. We need 2 things open for molecular docking. So I need the protein open as well. I've opened the ligand from here. Let's go File, Open. Let's open the protein. And we've created the protein. It's 5-rec-A-apo.pdbqt. Let's open that as well. Okay. So now we've got two things open. We've got the ligand and we've got the protein. But of course, the problem is that they are in, this is not the right space and it's not the right conformation. You can see there's an overlap of atoms where it is. It's not docked at all. This is an impossible situation. Can you see the overlap of atoms between the ligand and the protein? We're going to have to use molecular docking to move it to the right spot and to search conformations at the right spot to get a minimum of energy for that binding. Okay. So in the docking, yes?
I'm asking you, Elijah, your window for Autodocs.
Yes, okay, I'll make it larger. Okay. So here we go. Let's make it larger. And maybe what I should have done is made certainly the ligand at least a little bit more pronounced. But you see, it's not in the right spot. If I were to open the co-crystallized ligand, it would be at a different spot. Remember, I made this ligand using Marvin's sketch, and it's been optimized using X2B. So its position is just random at this point. So in the molecular docking procedure, what we're going to use, once we've got the ligand open using this menu and the protein open using this menu, we've got the two things open. The way the docking procedure is we normally move from left to right across this menu. Okay. So what I'm going to do is move left to right. We've opened the ligand. So the ligand, we don't have to deal with that menu. What we're going to start off with is we're going to start off with a rigid protein. So only the ligand is allowed to be flexible at this point. And it must fit into the protein. And we're not going to change anything about the protein, which means that I'm going to skip over the flexible residues window menu. Okay, so moving left to right, yes, we don't have to worry at this stage about flexible residues. So we're keeping the protein totally rigid. Okay, right. So the next stage in using AutoDock is that we're going to have to use the grid. And I'm afraid I've forgotten to do one thing for this, and this will make it clearer to you what's going on, is I need AutoDock. AutoDock 4 is what I need to be able to continue, and some of you have already installed it. Okay, so I see it's there. I certainly gave you a link. I certainly might have downloaded, I might have installed it. And some of you may have opened it. Hang on, there's downloads. Okay, AutoDock, proceed to the download page. Here we go. And I want the Windows, here we go. And what's really important is some of you installed it, and some of you actually found where it was installed to. That is very important. We need to know where on the computer it's installed to. And more than that, some of you tried to open it and it flashed, which is exactly perfect behavior. And you've tested that AutoDock actually works on your system. So I'm going to now install. Okay. And run is fine. Okay, here we go. Yes. Okay, so here we go. Now this is really important. It's in program files C, program files x86, scripts, these scripts, AutoDock 4.2. So just remember that directory because we're going to have to find that directory in order to get AutoDock to run. Okay. So just please make sure that is installed. And now we're good to go. Okay, so the next menu is the grid menu. And the grid is really about your search space. Where are you going to search to get your ligand to dock to the receptor? So in that, we're going to now go from top to bottom. We can't open a grid parameter file because we've never ever created a grid parameter file. So we are stuck. So the first menu option is not available to us. So the first option is macromolecule. Now, macromolecule, your choice is to open a macromolecule or to choose one. And what's interesting is your macromolecule is already open here. So you don't have to open it. You can simply choose it. And when you look here, please remember that the little one is the X2B as a ligand. Don't choose that. Choose the big one, the apoprotein. There we go, and select that molecule. Do you want to preserve these charges? It's fine. We've already added gastric charges. Either of these menus will be fine. You can go, I'm going to go yes, but you can go no if you want. And that's fine. And that's all set up. So it's good to go. Okay. So on the grid menu, from macromolecule, I've just chosen the macromolecule as being that. Okay. Right. Now, in your search area, what Autodoc does first is it requires a grid calculation. It requires us, and I suppose maybe the best way to describe it is what is the cost of placing a particular type of atom within the search area, so that when you search conformations of your ligand, you can very quickly build up what the cost is of all of the atoms in that search area. So we've got to set map types according to the atoms of the ligand. So when you come to the map types, please choose a ligand because it needs to know what atoms are in your ligand. And so I'm going to choose the ligand, and the ligand is the that one that I got from X2B. Okay. So now it knows, it absolutely knows that those nitrogens, those carbons, those aromatic carbons, for instance, in my ligand, are the types of atoms that it needs to set up. Calculations in the search area for. Okay, right. Now the most important thing is the grid box. And when you go to grid box, I don't know if you can see it there. There is the grid box over here, but it's at the moment, it's certainly not over my active site. Okay, so if we were to run the search in this area, we would not get good results because that is not on the active site. So what I want to do, you can use these buttons to move that search area around, and you just drag these buttons and it moves it to the right place. But we can do better than that. We've got an atom that's in the active site, and we know 22.7, 15.4, and 4.5 is a good position to search for the active site. So if I can just remember those numbers, 22.7, I'm going to type it here, 22.7. Let's try over here, 15.4. Okay, and we've got another. You can do molecular docking within Discovery Studio if you have a license. I have a license, but we don't have a site license for it. And so just be aware that this is a powerful tool for doing ligand docking as well. So 4.5 is the other one, 4.5. Okay, so you'll remember on previous ones we had seen the ligand up in this position. And so this is now positioned really nicely for that. You know, you can also change the search area. You can make the search area larger. And so that's what these buttons are for. So you can make those larger if necessary as well, if you're worried that you haven't searched that you haven't got it perfectly on the active site. But remember that the larger your search area, the longer you should run the molecular docking for, because there's more area to search. Okay. But once you have set your search area, you can see your ligand is not nearly where it should be. We've got to set it. after molecular docking, it will be in the right position. Okay. But once you've set the search area, please, on this menu, don't just close this menu. Go File, Close, and Save. You must close and save. Okay. Then finally, from the grid menu, what we can do is we go Output, and we're going to save a grid parameter file. And this is I'm going to call it 5REC, and this is the redocking. And it's .gpf, grid parameter file. Okay, so what I've done is macromolecule, I've chosen. Map types, I've chosen the ligand. Grid box, I set the XYZ. And then the output, I saved as a grid parameter file. Okay, you can edit the grid parameter file if you want, but I only recommend it when you've got a lot of experience with it. And there are things that you can do in the grid parameter file. For instance, if you've got non-standard atoms, you can always organize them. So if you've got, for instance, if you've got a gold atom, you can set parameters for gold, and in the grid parameter file, you can point to that parameter set. But that is, maybe if I just see if we can open it, that's what the grid parameter file looks like. You can see that the grid center is there. The grid center is there, and it's going to create a map. It's going to create a map for aromatic carbons, for aliphatic carbons, for nitrogen, hydrogen bond acceptor atoms, for oxygen acceptor atoms, hydrogen bond donor atoms it's going to make, and for just normal nitrogens, it's going to create a map, because these are the different atom types that were in my ligand. And so it needs a map for each type. There are also desolvation electrostatic maps it's going to create. That's really important. And so it's going to create those maps. It's got the receptor types. These are all the different atom types in your receptor. These are all the different atom types in your molecule. There's the size of the grid. But you don't really need to look at it. We can just save it as a GPF, and we're good to go. Okay. Now, it'd be nice to run AutoGrid and generate those maps. So if I look at my folder, you can see there are no maps in this folder. You see there are no maps in this folder. After we've run AutoGrid, AutoGrid is going to create those maps. So let's have a look, run, and let's run AutoGrid. Right, so the first thing we do is on the parameter file name, I recommend that you rebrowse for the parameter file name. That grid parameter file we just created, browse for it. Oh, I might not have saved it right. Okay, so grid output, let's save it as a grid 5rec redoc. It didn't put the GPF at the end. Okay, 5rec redoc.gpf. So when you go grid, please, on your output, when you go save GPF, make sure it's got a .gpf at the end. So that when you come here and you browse for it, you can see it. It'll only show you the .gpf there. And what's interesting is that when you tell it what the grid parameter file is, it knows then what to call the grid log file. So the grid log file is going to be over there. Okay. The final thing you need to do is you need to tell it where the program is. And you can, on Windows, set your paths, but I find maybe it's simpler. We know that it was installed, AutoGrid was installed in C program files, the Scripts Institute Autodoc 4.2, and it's AutoGrid that we want. Okay, so search for your AutoGrid. That's the program that will flash up. And the reason it flashes up when you just try and open it alone is because it hasn't given us all of these parameters. It doesn't know the grid parameter file. It doesn't know the log file. And then now we can launch it. So please select your parameter file and select the program AutoGrid 4. Once you've selected both of those with the browse and this should run without a problem. Okay. Please be patient when it runs. You can see this window up the top. That means it's trying to calculate the maps for each element in the search space. Okay. So now what we've done is we've set up a grid search area for this docking experiment. Okay. If I go to my folder, you can see now there should be some maps. See, there's a map file that's been created. See all these maps that have been created, and that's the maps it's going to need to perform the docking experiment. Okay, so AutoGrid 4 is your first step. Okay, you can open these maps in here, and so let's just see. I think it's this button here. Yes, here we go. So if you have a look at the 3D grid rendering, let's just add a grid. And let's maybe look at the aromatic carbons, or maybe hydrogen donors. Hydrogen donor. The hydrogen donor map is in this area, which is really nice. Okay, but of course it'd be nice to see if we can do it as a volume. Perhaps we can do it as a volume, and so you can see areas where hydrogen donors would be really good in terms of molecular docking. You see those areas there. We can expand it. Maybe I'll do it as an isocontour. And you've got to shift and mouse click in that to create areas. So there we go. There we go. So that shows you the map it's created for hydrogen bond donors. But that's not the only map. The other maps that will contribute. And so it now knows the cost of placing or the advantage of placing a particular atom at a particular point in the search area. Okay. And that speeds up the whole molecular docking process. And so molecular docking will work a lot faster. Okay, we've got 10 minutes, and I think that might be just enough to get molecular docking on the go. Okay, so let's see. We've gone from left to right. We've done the ligand menu. We've done the grid menu, but of course, remember on the output, we save it with the GPF extension. Now we can do molecular docking. So on docking, again, we can't open a docking parameter file. So we've got to just set the receptor file name, the rigid file name, because it's a rigid protein. And the rigid protein is 5rec-apo.pdb. Okay, so it's 5rec-apo was the one I had. And then on the docking, the ligand, I'm going to choose it. The ligand was the XTB ligand, and just accept what it throws at you. Okay, so we've done macromolecule, we've set the rigid file name, ligand, we have chosen. Let's have a look at the search parameters. We're going to be using genetic algorithm. This looks fine. And of course, the number of runs, 10 runs, may be a little few. When we come to the lecture slides, the problem is that we need reproducibility. So if you only do the experiment, if you only run it 10 times, the chance is that all 10 will give you 10 different results. But if you do it 100 times, then you'll start to see reproducibility coming through. And your best docking, maybe 10 of those 100 would be. But of course, it makes it a very long experiment. Of course, maybe I can leave my laptop running. I'm going to do 100. So what I'll do for research is I'll probably do 100. For research, though, I'll probably make this long here. I'm not going to make it long for the maximum number of evaluations. Okay, we'll deal with these parameters, and I'll accept that. Okay, and then docking. We've set the rigid file name. We've chosen the ligand. We've set the search parameters to be generic algorithm. Let's just check the docking parameters that we're happy. The defaults are fine. We're going to accept the defaults. And then the docking, let's see, output. Please, on the output, can we use the Lamarckian genetic algorithm? The output, and it's a Lamarckian genetic algorithm. And let's just say it's 5REC redocking. And please give it the DPF extension here, like that. So please make sure that the extension is saved. Okay. So the docking here, we've set the rigid, we set the ligand, we set the search, we set docking parameters, and the output is Lamarckian, and we've given it a DPF extension. And again, you can have a look at the DPF that's created by looking at that edit. Okay. So the final thing that we do, we've all set up for the docking run. The final thing that we need to do is actually run the docking. And so we can run AutoDock itself. So we've run AutoGrid before. Now we can run AutoDock. And when we run AutoDock, please reopen the parameter file name, because then it fills in what's necessary here. And on the program path name, let's just browse the AutoDock for. Again, I'm going to go on my C drive, program files, the Scripps Institute. There we go. AutoDock 4.2, and now it's AutoDock 4. Okay. Right. Please be very careful. Notice that in my folders, I don't have spaces in the name. And then sometimes it can cause problem to have spaces. It might not always cause a problem, but just be careful. I try to keep away from spaces in the name, but it seems to work. There are spaces in that name and it still seems to work. So just be careful. I'm going to launch that, but certainly in your parameter file name, please don't have spaces in that name, and please don't have spaces. Okay, I'm going to launch it. Okay, and this is a good point because I've asked it to do 100 sets, and it will get the best result out of 100, and we can explore that. But it's really good if you see this happening. It means that the docking is working well. If there's a problem in your docking, this window will disappear immediately, and you'll end up with your errors immediately, and it won't carry on running. But the fact that it is running without problems means that we have got docking on the go correctly. Okay. Are there any questions? Right. So this is probably not a useful docking. I've got the original ligand to the original protein, but it's useful for validating my docking procedure. What would be more interesting is if I had one of my own compounds and I were to dock that against this, then I would be able to evaluate my own compound in terms of its efficiency in binding to this particular receptor. Okay. Are there any questions? We've got time for maybe 1 or 2 questions. Okay. I've been through a lot, so it's not going to be the only time I run through this procedure again. Certainly, next lecture I'm going to run as usual. I'll do a lecture, but in the practice, I'm going to come back to this. And I'm going to try and run the molecular docking process for some other systems. Please, if you run into trouble with your molecular docking, a screenshot. Show me what's going on your screen. That will give me detail. Or if you copy files onto the cluster and say you're working with this file and this file, and you tell me where to look, I can copy them onto my machine, and I can try and troubleshoot what's going wrong with your systems. Okay. Questions?
Prof.
Yes?
On that other last week's lecture, when you were trying to save it as a PTPQ and then it brought error message.
Yes.
I did procedure and then I was able to save the PTPQ.
Oh, well done. How did you do that?
No, it never gave me an error message. I just followed everything that you were doing, but then I never got the error message.
Okay, so maybe it's my system that's causing trouble. You'll notice that what I did today was that I did it in stages. So I saved the APO. After I deleted stuff, I saved it. And then I started afresh. So those of you, if you're getting errors, start afresh, like what I did today. and you will in the previous session, and then it will work. But thank you for trying it through, and thank you for testing that it does work. Okay.
Okay.
Yeah. And on my Linux system, it seems to work absolutely fine. I normally work on Linux, not on this particular computer. But maybe I should have tried it before to check it worked. But thank you for letting me know.
It's all right.
Okay. As always, things are becoming a bit easier, so I might be more responsive to questions. If you've got questions, please email me, and we'll try and troubleshoot as we go along. But I'd like you to try and set up docking procedures as soon as you can. And we're out of time now. Okay, so please email me any questions you have.